Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 1219, path with maximum gold. In a gold mine grid of size m into n, each cell in this mine has an integer representing the amount of gold in that cell, 0 if it is empty. Return the maximum amount of gold you can collect under the conditions. Every time you are located in a cell, you will collect all gold in that cell. From your position, you can walk one step left, right, up, down. You cannot visit same cell more than once. Never visit a cell with 0 gold. You can start and stop collecting gold from any position in the grid that has some gold. So they are asking us to find. We want to collect the maximum gold under these conditions. Okay, we cannot visit one more time that same place, and we cannot visit the 0 gold. Fine. Just see this example. 060587090. So this is my example, and what is our answer? 987. So see this. What are all the possible paths? First possible path is 685. Okay, second possible path is 687. Third is 689. Other than this, whether we can go? No. From 5, 586, 587, 589. From 8, 86, 87, 89, 85. Any one of them. You can take from 4 direction. Okay. From 7, 7, 8, 9. Okay. 7, 8, 9. Other than that, there is no more. Okay. Now with 9, I can traverse from 986, 985, 987. What is the maximum? 987. So that's why they have given what? 987. Or you can also traverse from 789 also. Both are same. You want only maximum, right? Maximum sum. So both sum are equal. So I will written what? This 24. Hope you understand this. Right? Same for this second example also. We will take what? 1, 2, 3, 4, 5, 6, 7. After this, we will take from this matrix. And what is the output? It will be 28. Fine. So the first approach that comes into our mind is start from the maximum gold. Okay, start from the maximum gold. Now traverse from this gold which has a maximum gold. Traverse to the direction which has my maximum gold. Okay, from 9 I can traverse to this 8. Okay, from this 8, whether I can traverse to 6? No. 5? No. Whether 7? Because 7 is the maximum among these 3, right? So I will traverse to 7. Now I got an answer, right? You may think like this, but it is not a case. This is what? Greedy. The approach now we are seeing is greedy. But this greedy fails. Why? Because just take for example, first of all, we want to start from where? By using this greedy approach means from where? We want to start from the maximum element. So what is the maximum element? It is 12. Whether I can move anywhere? No, I cannot move anywhere, right? So 12 is my answer. Okay, I can also traverse like, I will take this 10, then 8, then 3, then 5, then 4, then 2, then 1. Whether it is maximum, right? So this should be my path. So here the greedy fails. So how to do this? Recursion and backtracking. Just use recursion and backtracking. Okay, how to use this recursion and backtracking? They have clearly given that we can move up or down or left or right. So these are the 4 directions we can move, right? So these are the 4 directions we can move. Okay, fine. Now the next step is to find whether we have traversed the place or not. Okay, so for that we can use a visited array or set. Anything. I use a visitor set. Okay. Now these are the informations we need to create a recursion function, right? Okay. First of all, what should be my parameters? My parameters should be what is the index of that cell. If take for example, I am the 6, it will be 0, 1, right? So I want to give this as I, j. So this is mandatory. Then I have to take that set, right? So v. Okay. Anything else we want to keep track? No, that's it. So we want these 3 parameters. Fine. Then this is my function. Now from this function, what are all the functions we should call? I should call 4 functions. What are they? One is f of I plus 1 comma j and v, then f of I, then j plus 1, then v, then f of I minus 1 jv, then f of I j minus 1 v. So these are all the functions we have to call, right? This is what? This is the down. This is what? This is right. This is top or up. This is left. Can you understand this? So these are all the 4 recursion calls I have to do, and I have to find which is the maximum. So I want to find the maximum among them. Okay, maximum among them, and that current value should be added to it. So what is the current value? Let us take the matrix. What is the matrix? It is a grid, right? So we want to return what? We want to return grid of I and j plus this whole value. Now it is simple, right? It is simple. Okay, now let us think about the base case. What should be my base case? Okay, tell me about the base case. Fine. First of all, if the index falls apart from the valid index, right? So if, take for example, row index is I, right? So I should be less than m and should be greater than or equal to 0. So this is my I range. And what is my j range? J range should be 0, above 0 and below n, right? If it is not a condition, then what should I do? I should return 0. Return 0, because there is no such things I can go apart, right? See here, if I reach something like see here, 10 to, these are 2 elements. If I reach from 10 to 2 and 2 here, whether there is some elements, no, right? So I should return 0. That's why I return 0. Okay, now what is the second case? If the current index value is 0, then I should return what? 0. I should not go further. Cannot go further. Okay, if what is the case? If a grid of I and j is equal to 0, then what should I do? Just return 0. Okay, fine. Now next step, what should I do? Okay, whether I can visit a cell again? No, right? So to not visit the cell again, we should take what? If I and j is in visit, then what should I return? Again I will return 0, because there should not be any other function call, right? So these are all my base case, right? And this is my body of the function, right? This is my body of the function. Fine. So in this body of the function, we should add what? Add that current index into my current index into my visitor array, and at last I want to remove those indices. After I finished this all process, I will remove it. Can you understand it? When I am traversing, I will include that in our visitor, such that I should not again go to that cell, and after finish those recursion calls, I will remove it while backtracking. Fine. So this is how our code going to look like. Fine. Now let us see the code. It is simple. See here, def path of I comma j. We can also give comma b in other languages, but in Python it is all accessible inside this class, right? Sorry, inside this function, member function, right? So I haven't given it. Now if it is not in a range, then what should I do? Then I should return 0. If the grid value is 0, what should I do? I should return 0. If the visited array, here I use what? Visited matrix. Here I used what? Visited matrix, which means see here. This is quite concept for visited matrix. So we can use a visited matrix or visited set. But if I use a visited matrix, see here, what is a grid size? It is 3 into 3, right? So I will take a 3 into 3 matrix and make all things as 0. The 0 represent what? The 0 represent it is not visited. And once I visited, I will change this to 1, then 1, then 1, like that. Again, when I backtrack, I will make this as again 0, which means what? I can again we can visit that like that. Okay, so here we can use what? We can use this r. We can use v of ij is equal to 0. Sorry, 1. Make this as 1. And when I am backtracking, I will do I comma j is equal to 1. Sorry, 0, which means I haven't visited. So we can also use like this. Okay, fine. Now v of I comma j is equal to true. I use true and false. There I said you like 0 and 1, right? Now left is equal to grid of I comma j ij plus path of I comma j minus 1. So this is my left. Left is what? I comma j minus 1. Then right is what? I comma j plus 1. Then same down is what? I plus 1 comma j, and up is what? I minus 1 comma j. And again I will make the visited as what? False. It means what? I can visit that cell again, because when I'm backtracking, that is excluded, right? So I make sure that I should make this as false or 0, anything. Now return max of up comma down comma left comma right. So simple, right? And for I in range of len of grid, for j in range of len of grid of 0. So I'm just traversing in the grid, and I'm going to find what is the starting point such that I can get a maximum value, right? See here. So see here. In this, I can start from this 1, or whether I can start from 0. No, I can start from this 7 or 2 or 6 or 3, 4, 5. I can start from wherever I want, right? So I want to start from each and every point and check whether which is maximum. I should take this result. Okay. Now at last I will return my result. That's it. Let me submit it. Yes, it is submitted successfully. Now it's time to see a slight modification in this code. See here. Here we used extra auxiliary space, right? What is the extra auxiliary space? We use a visited matrix, right? So to avoid that visited matrix, we can use the given matrix itself. But how can we use the given matrix? You may ask. See here, I will assign the gold is equal to grid of I comma j. First I will assign gold as grid of I comma j. Now I make that grid as 0 because I took the all gold, right? So it remains what? 0. And I finish all the recursion, right? Recursion. Then again I will make that grid as what? Gold. When I backtrack, I took as our answer, so that gold will be taken, so it will be 0. When I excluded that from my answer, that gold should be replaced there, right? So that I just assign that gold again to the grid. Now I will return the max upon up, down, left and right. These are all same code except this 2 lines. We haven't used what? Visited matrix. Let me submit it. Yes, it is submitted successfully. And another thing, here we use what? If grid of I comma j is equal to 0, then return what? 0. So that only when I put this as 0, it is like a visited. Okay. If grid of I comma j is equal to minus 1, if there is a condition, take for example, if there is a condition, I will make this as what? Minus 1. Okay. Now at last I want to say you something. Don't use left, right and top, down like that. No. Don't use like that. Make sure use like this. Direction is equal to 1 comma 0, 0 comma 1, minus 1 comma 0, 0 comma minus 1. It looks like a compact answer. Okay. See here I used what? 4 lines, right? By using this, we can traverse easily. In higher problems in dynamic programming, we want to traverse in more number of directions. For example, there's a problem called night dialer, I think. In that, we are going to place our knight in each and every direction in our chessboard, and we want to find how many possibility. So for that, we want to give this direction as like 8 direction, I think so. A knight can move 8 direction, right? It's 8 direction. So we want to give those 8 direction inside this, or else we will write what? End up in writing 8 lines here. Okay. So this is a short form. See here, if it is 1 comma 0, it means what? 1 is added to the row, which means what? 1 is added to the row means down. I move down. If 1 is added to the column, then I move what? Right. If minus 1 is added to the row, I move what? Up. If minus 1 is added to column, I move what? Left. This is what the direction represent. Everything is same as the previous thing, but see here, this only line is changes. Result is equal to 0. Then for x comma y in direction, which means x will take the first value. So this 1 will be taken and y will take the second value. The 0 will be taken. Like that in each and every tuple it will take the value. Now result is equal to max of result comma gold plus path of I plus x plus I plus x comma j plus y. Can you understand what I done here? While adding those things, I will move left, up, down, right, like that, and I will take the maximum among them and I will return it. After that, it's same as the previous codes. Okay, let me submit it. Yes, it is submitted successfully. Now it's time to see the time and space complexity. Okay, let us see the time and space complexity. What is the time complexity and space complexity analysis? See here. So for each and every cell, how many times I am running the recursion call? I have 4 recursion call. So for one cell, I have 4 recursion call. Okay, for n cells, how many recursion calls I can make? I can make a 4 power n recursion call. 4 power n recursion call, and this n represent what? Each and every cell. So into m. So this should be the each and every cell, right? We have multiple cells. What are they? Row into column cells. So that's why I used here. And we are going to start with each and every point. So it will be m into n. This is going to be time complexity. Now, what is my space complexity? I can say my space complexity will be, I will traverse each and every time in the stack, right? I will traverse each and every time in stack. At the most, in a worst case, I can traverse up to what? N into m. So this is my time and space complexity analysis for this approaches. Thank you.